Something ancient drifts between the stars. It carries no engines, no heat, no voice, only momentum and memory. In the darkness beyond Neptune, it glimmered for a heartbeat of cosmic time, and every telescope that turned its gaze felt the same shiver of recognition. We had seen a traveler before, but never one quite like this. They called it 3I Atlas, the third object ever confirmed to come from another star. A simple name, almost bureaucratic, yet behind those letters lay the story of a journey so vast that the human mind can only touch its edges. It moved too quickly to belong to the sun, its path bending not into an orbit but a hyperbolic escape, a mathematical signature of exile. The first detections came quietly. An automated sweep of the Hawaiian sky, the asteroid terrestrial impact last alert system noted a flicker that refused to behave. Astronomers gathered around screens, their algorithms whispering possible interstellar origin. Within hours, observatories across the world trained their mirrors, and in that instant, the visitor became more than data. It became a question. What story did it bring from beyond the heliopause? What chemistry had it inherited from the void between stars? Why did its brightness pulse without a comet's tail, and why did its surface appear altered, scarred, perhaps by something unseen? We have met to others before. Oumuamua, the first a thin, tumbling, reflecting sunlight like polished stone. Borisov, the second. A true comet, rich in frozen gases, its tail a familiar sign of solar heat. But 3I Atlas seemed to belong to neither lineage. It glowed like a comet, yet behaved like a shard of rock. It carried the luminosity of ice, but the discipline of a solid body forged in deep time. As images multiplied, scientists traced its curve through the sky and realized it had arrived not recently, but long ago, traveling for millions, perhaps billions of years. And then a new idea began to take shape, the possibility that during that voyage, the object had been transformed by the galaxy itself. The Milky Way is not empty. It is filled with a rain of invisible energy, tiny projectiles born from dying stars, atoms stripped of electrons and hurled into eternity. They are called galactic cosmic rays, protons and heavier nuclei traveling near the speed of light, their energies so immense that they pierce worlds, etch minerals, and rewrite molecules. If 3I Atlas truly wandered the galaxy for eons, then every square centimeter of its surface would have endured that relentless bombardment. Each particle a needle of change, altering bonds, darkening ices, creating new carbon chains. In laboratories on Earth, we simulate such storms, and the results are striking. Irradiated ices turn red, transparent frost becomes tar. Simple molecules give birth to complex organics. Could that same alchemy have unfolded upon 3I Atlas, a frozen script written by cosmic radiation? Halfway through its brief encounter with our sun, astronomers noticed that its color, its subtle hue in reflected light, did not match fresh ice or ordinary dust. It looked aged, weathered beyond the scale of planets. And from that clue arose the current mystery: is 3I Atlas evidence of galactic cosmic ray processing? Before we chase that answer, pause and imagine the scale. Between one star and the next lies not silence but a sea of fury. Each atom that strikes a traveler like 3I Atlas carries the memory of supernovae of suns that exploded to scatter the elements of life. Every impact is both destruction and creation. If that thought moves you, if you want to follow this trail across the dark ocean of interstellar space, take a moment, subscribe, join the mission. Because what we uncover next is not just the story of a rock from another system, but the record of our galaxy's hidden weather, the cosmic rays that shape every world they touch. When the telescopes tracked 3I Atlas to the edge of the solar system, its light faded, but the questions only deepened. Where did it begin? How long had it drifted between the stars? And what signatures, carved by radiation older than the Earth itself, still linger on its skin? As night fell on observatories across the planet, data poured in spectra, brightness curves, tiny fluctuations whispering secrets about its composition. Researchers compared notes, and one by one they began to see patterns, the same reddening seen in cosmic ray damaged dices, the same subtle absorption lines that appear when organics are forged from simpler compounds. It was as though the object had been painted by the hand of the galaxy itself. So begins our story. A tale of light, energy, and endurance, a fragment of another system, processed by cosmic rays, passing through our sky for a moment to remind us that even in the darkest regions of space, the universe is never still. And as 3i Atlas fades into the outer dark, its legacy remains in the data it left behind, a riddle written in radiation, waiting for us to read. Across the quiet gulf between the stars, fragments wander like forgotten letters, each carrying a story from a distant origin. Interstellar visitors are not rare in theory. Our galaxy should be full of them, but to our eyes they remain elusive, faint sparks slipping through the glare of our own sun. Until recently, we had never truly recognized one. Then, one after another, they began to appear. Oumuamua in 2017, Borisov in 2019, and now 3i Atlas in 2024, 3 points on a new map of cosmic migration. Each revealed a different face of the same phenomenon, objects flung free from their home systems, wandering between suns for millions of years. To understand 3i Atlas, we must understand what it means to be an interstellar traveler. When planets form around a young star, billions of fragments are thrown outward in chaotic orbits. Most fall back, a few are caught by neighboring suns. But the rarest find the exact momentum to escape forever. Once adrift, they are citizens of the galaxy itself, no longer belonging to any single world. Over time, they are battered by micrometeoroids, heated by starlight, and irradiated by cosmic rays until every molecule bears the scars of that endless passage. Astronomers call these bodies interstellar interlopers. Their chemistry is the combined history of everything they have encountered. Some are pristine, frozen archives of early planetary systems. Others are heavily processed, transformed by radiation into dark, carbon-rich relics. By studying them, we glimpse what our own solar system might look like from afar. Oumuamua was the first shock. It entered from above the plane of the planets, moving too fast to be bound by gravity. It tumbled strangely, reflecting sunlight and flashes that suggested an elongated shape. No tail, no gas, yet it brightened as though something invisible was pushing it. Even now, its true nature is debated: a fragment of rock, a thin sheet of frozen hydrogen, perhaps even the remnant of a destroyed comet nucleus. Borisov was simpler, almost comforting, a classic comet, rich in cyanide and water ice, venting gas as it neared the sun. It looked familiar, yet its chemistry differed subtly from anything local. It told us that other planetary systems build comets much like ours, and yet not quite. Then came 3i Atlas, smaller, dimmer, discovered later in its passage, but immediately puzzling. Its brightness rose too quickly for its distance. Its trajectory, perfectly hyperbolic, no visible jets. Its color, a muted red, not the fresh pink of new eyes, but the aged crimson of material baked by cosmic radiation. It was as though the object had been weathered for ages in an environment far harsher than interplanetary space. When scientists examined its light curves, they found irregular rhythms, small variations hinting at a complex shape, perhaps a rotating fragment rather than a sphere. Its reflectance spectrum suggested tholins, complex organic compounds known to form when ices are bombarded by energetic particles. Such materials coat the moons of outer planets and the surfaces of Kuiper Belt objects, but in 3i Atlas they seemed even darker, more ancient. What made it stranger was the absence of typical comet behavior. Approaching the sun should have triggered outgassing. Instead, it remained quiet. Some proposed that its volatile materials had long since been exhausted. Others suggested that it was never rich in volatiles to begin with, that it might be the rocky core of something once icy, stripped bare by eons of exposure. To picture that journey, imagine a shard ejected from a forming system somewhere in the Perseus arm. For millions of years, it drifts through thin clouds of interstellar gas. Every second, high-energy protons slam into its surface, breaking molecules, forging new ones. Gradually, a dark crust forms, an insulating skin that preserves whatever lies beneath. When, by chance, the object passes through our solar system, we see only that scarred exterior, an archive of cosmic history sealed in radiation. Spectroscopic comparisons confirmed what many suspected: the optical slope of 3I Atlas matched no fresh solar system body. It mirrored instead the reddened hues of outer belt asteroids, of Trojan moons, of material known to be processed by cosmic rays. Its surface reflected less light, absorbing more energy as though coated in complex carbon chains. To the trained eye, that meant time-long exposure, slow change. These were the anomalies that set 3I Atlas apart. Too dark for a young comet, too smooth for a fragmented asteroid, too quiet for anything freshly thawed. Every observation hinted at age and endurance. It was not merely visiting our system, it was passing through after a lifetime in the interstellar abyss. In this sense, 3I Atlas became more than a curiosity. It became a messenger, carrying chemical fingerprints from places we may never see. Each photon reflected from its surface crossed billions of kilometers to reach our detectors, each one shaped by processes far older than our sun. And within those photons lies the evidence that something invisible has been sculpting matter across the galaxy. Before long, astronomers began to use a new phrase when describing 3I Atlas, galactic cosmic ray processing, a quiet term, almost clinical. Yet behind it rests a profound idea that the universe itself is a laboratory, and this fragment is one of its experiments. If this story fascinates you, if you want to follow every chapter of how scientists decode these celestial clues, take a moment to subscribe to stay with this journey as we go deeper into the science that links radiation, chemistry, and time itself. Because what comes next is the heart of the mystery. We will step beyond observation and into the invisible domain of energy, the cosmic rays that travel faster than thought, that strike every world, every molecule, every traveler between the stars. Only by understanding them can we grasp what truly happened to 3I Atlas, so keep your curiosity close. The next segment begins where light ends, with the storm of particles that defines the space between stars. Between every star lies a storm without thunder, an ocean of energy without light. It moves unseen, yet it touches everything: the smallest grain of dust, the largest planet, even the cells within our bodies. This storm is made not of wind or water, but of particles born in catastrophe. They are the messengers of destruction and creation, galactic cosmic rays. Long before humanity learned to split the atom, the universe was already performing its own nuclear experiments. When massive stars reach the end of their lives, they collapse inward and then explode outward in a supernova. In that instant, the shockwave accelerates fragments of atomic nuclei, protons, helium, iron up to near the speed of light. Each fragment becomes a bullet of pure energy, traveling through the galaxy for millions of years, guided by magnetic fields so tangled that their path resembles smoke in the wind. Most will never hit anything. The space between stars is vast, and for every particle that strikes a planet, billions pass through empty void. But given enough time, they touch everything. They strike asteroids, comets, interstellar dust, and every wandering traveler like 3I Atlas. Each impact is minute, but the sum of billions across millions of years becomes a form of cosmic weathering, a slow sculpting by radiation. When these particles collide with matter, they trigger cascades of secondary reactions. Atoms are split, molecules broken apart and rearranged. The once clear ice of a comet's surface turns dark as carbon chains form. Transparent crystals become opaque, metals sputter and flake, organics mutate into ever more complex compounds. To cosmic rays, matter is both canvas and clay. On Earth, we are shielded by a magnetic field and thick atmosphere, yet even here, cosmic rays reach the surface. They leave tiny traces in minerals, measurable isotopes that reveal how long a rock has been exposed to space. Apollo astronauts found this evidence on lunar samples, microscopic scars in glass beads created by the impact of high-energy particles. In meteorites, we find the same isotopic fingerprints, proof of long exposure to galactic radiation before falling to our planet. Imagine, then, an object like 3I Atlas, adrift for millions of years with no protection at all. Every side of its surface becomes a palimpsest of collisions, a story etched atom by atom. The longer it drifts, the thicker the crust of alteration grows, sealing away the unprocessed material beneath. Its surface becomes a time capsule, its chemistry a record of the galaxy's invisible violence. Scientists have tried to recreate this process in the laboratory. They chill mixtures of water, carbon monoxide, methane, and ammonia to near absolute zero, simulating the ices found on comets. Then they bombard them with accelerated particles. The result is astonishing. The ice darkens, turning reddish-brown. Spectral analysis reveals the formation of complex organic stolons, the same substances suspected on the surface of Titan and Pluto. These molecules, forged in radiation, are the building blocks of life's chemistry. So, cosmic rays are not merely destructive, they are also architects. They create amino acid precursors, sugars, hydrocarbons, the raw ingredients from which biology might one day emerge. In this way, they blur the line between the violent and the vital. They are the heartbeat of the galaxy's chemistry, endlessly recycling matter through transformation. The journey of a cosmic ray is almost unimaginable. Born in a supernova's shock front, it travels through magnetic fields that twist its path for millions of light years. It may pass through star-forming regions, cross the galactic plane, or weave among clouds of molecular gas. Each encounter steals a fraction of its energy, until at last, after perhaps 10 million years, it slows enough to be trapped or absorbed by matter, perhaps by a lone interstellar fragment like 3I Atlas. In that impact, a fraction of the star's ancient power is released again, invisibly changing the chemistry of whatever it touches. When astronomers speak of cosmic ray processing, they mean this endless cycle of exposure and renewal. A world left long enough in open space will become darker, redder, less reflective. Volatile compounds evaporate, and new ones form in their place. It is the universal patina of time. If we could look closely at 3I Atlas under a microscope, we might see layers of this transformation beneath the outer crust, fresher material untouched since its birth. Above it, a boundary of amorphous carbon created by the ceaseless bombardment of cosmic rays. This duality, creation through destruction, is one of nature's oldest patterns. The same events that tear apart stars also seed the chemistry of new worlds. Supernovae fill the galaxy with metals, and their shockwaves accelerate the very particles that later carve their signatures onto wandering stones. Every atom of iron in our blood once rode the same cosmic tide. Understanding these rays is not just an exercise in astrophysics, it is an act of connection. It means recognizing that we, too, are shaped by the same energies that sculpt distant objects. Every breath of air contains isotopes born in cosmic collisions. Every cell in our bodies bears the quiet imprint of the universe's oldest storms. When 3I Atlas entered our solar system, it brought with it a chemical memory of those storms. Its faint red glow, its lack of active jets, the subtle fingerprints in its spectrum all point to a surface long bombarded by galactic radiation. If we can read those traces, we can glimpse the conditions of interstellar space itself, places unreachable by any spacecraft. That is the promise of this mystery. Through a single drifting fragment, we can study the history of energy in the Milky Way. Each particle that once struck 3I Atlas now tells us something about the stars that forged it. Every change in its color and composition is a clue to the invisible architecture of our galaxy. So, when scientists say that 3I Atlas shows evidence of galactic cosmic ray processing, they are saying that its surface is a story one written not by light, but by the absence of it. By invisible forces that have worked patiently for epochs. A story of how matter learns to endure, how the smallest fragment can carry the memory of entire suns. In the next chapter, we will follow that evidence, tracing how astronomers uncovered the signs of this radiation in the data, how the light from one tiny traveler revealed the fingerprint of the galaxy's most powerful storms. When scientists first turned their instruments toward 3I Atlas, they expected to see the ordinary. A faint smudge of light, a predictable spectrum, another cold body passing quickly through the solar system's outer frontier. But the data they received told a subtler, stranger story, one that began not with brightness but with color. Light, when broken into a spectrum, is language. Every dip, every rise, every shade is a syllable in the sentence of matter. Not the red of a glowing ember, but the red of age of surfaces darkened by chemistry rather than heat. This gentle shift was the first whisper that something unusual had happened to this traveler. Astronomers compared its spectral curve to known objects, icy comets, rocky asteroids, Kuiper belt remnants, none matched perfectly. The slope of its reflected light was steeper, its color richer in deep crimson tones, the same hue seen on bodies that have spent eons bombarded by radiation. Such redness, subtle yet undeniable, is a hallmark of cosmic ray processing. In laboratory conditions, ice mixtures irradiated with high-energy particles take on precisely this tint. Further study came through photometric observation. As 3I Atlas rotated, its brightness wavered, small fluctuations suggesting an irregular shape, perhaps a spinning shard or fractured nucleus. But beneath those rhythms lay constancy, the absence of cometary activity, no jets, no halo of gas, no escaping dust. A silent traveler, this quietness told another tale. If 3I Atlas had ever been rich in volatile ice, cosmic rays could have long since altered or exhausted them, sealing the surface under a crust of organic residue. From the vantage point of the Very Large Telescope in Chile, astronomers obtained spectra that hinted at complex hydrocarbons' broad absorption bands near wavelengths known to correspond with carbon-hydrogen bonds. Similar patterns appear on the surfaces of trans-Neptunian objects, bodies that have endured radiation for billions of years. To see the same on a fast-moving interstellar object suggested that 3I Atlas had been traveling through the galactic medium long enough to acquire the same scars. There were other clues. The object's albedo, its reflectivity, was surprisingly low. It absorbed most of the sunlight that touched it. Fresh ices reflect brightly, aged, radiation-darkened materials do not. Measurements placed 3I Atlas among the darkest natural bodies ever observed, its surface more akin to tar than snow. This deep blackness is the visual residue of cosmic ray impact. Each collision rearranges molecules into carbon-rich films that swallow light. In archived data from other telescopes, researchers noticed a peculiar spectral flattening and absence of the crisp features expected from crystalline ice. Instead, the spectrum looked blurred, softened by an amorphous surface layer. That layer is a known consequence of radiation damage. When cosmic rays strike crystalline ice, they break its lattice, transforming ordered structure into glassy disarray. The same effect appears in samples returned from comets exposed to solar wind, but on 3I Atlas the transformation seemed deeper, more complete. Taken together, these fingerprints formed a pattern: red in color, low albedo, muted spectral lines, chemical hints of organics, silence where outgassing should roar. Every sign pointed toward a surface altered not recently, but over cosmic time. Laboratory studies reinforced the case. When scientists compared the spectra of 3I Atlas with those from simulated cosmic ray experiments where frozen mixtures of water, methanol, and carbon monoxide are bombarded with energetic ions, the match was uncanny. Both displayed the same red slope, the same broad absorption near 3 microns, the same dark continuum. It was as if nature had run the experiment for us, using the galaxy itself as the accelerator. The depth of the alteration could even be estimated. Cosmic rays penetrate roughly a meter into solid ice before losing their strength. If 3I Atlas has wandered unshielded for tens of millions of years, then every square meter of its surface would carry a mantle of material transformed by radiation. Beneath that crust perhaps lie unprocessed ice's preserved relics of its formation. But the outer shell, the part we can see, is pure history, a fusion of energy and time. One of the most persuasive arguments came from thermal modeling. When the object neared the sun, its temperature rose slightly, but not enough to trigger outgassing. That restraint made sense if the surface had become desiccated and sealed by carbonaceous compounds. Such a coating, produced by cosmic rays, can trap volatile materials beneath, insulating them against heat. 3I Atlas appeared to be wrapped in its own protective armor, a layer formed by the very forces that stripped other bodies bare. This convergence of evidence led astronomers to a quiet but profound conclusion. 3I Atlas was not merely passing through our system unchanged. It carried on its surface the chemical and optical memory of its galactic journey. Its redness was the pigment of radiation. Its darkness, the shadow of countless impacts. Its silence, the final consequence of being processed beyond activity. From Earth, we could see only a point of light, yet within that point was a record of energies far greater than any our planet could generate. Each photon we captured had bounced from a surface molded by cosmic rays older than our solar system. Every measurement was a conversation with history. This is what makes the study of interstellar visitors so extraordinary. They are not mere wanderers, they are witnesses. They have seen what we cannot. The deep environment of the galaxy, the regions between stars where radiation, magnetism, and dust weave the fabric of space. When one passes close enough for us to measure, we are, for a brief moment, reading the diary of the Milky Way itself. 3I Atlas reminded us that the galaxy is not still. It is alive with movement and energy, constantly reshaping its matter. Cosmic rays are the sculptors, objects like 3I Atlas, their enduring art. And though the visitor now recedes into the cold dark beyond the reach of our instruments, the data remain a portrait painted in invisible strokes. Each observation adds another line to the story, a story written not in ink but in radiation. In the next part of this journey, we follow 3I Atlas beyond our sun, tracing its imagined path across the galaxy. We will explore how such travelers endure the storms of interstellar space, how chemistry changes with distance, and how, in the vast silence between stars, cosmic rays continue their patient work. Across the grand expanse of the Milky Way, 3I Atlas has wandered longer than any civilization has existed, perhaps longer than life itself on Earth. Picture a fragment no larger than a mountain, sliding through a sea of darkness where stars are islands and the space between them is not emptiness but a field of quiet violence. Its journey began somewhere far from here, maybe in the cradle of a distant star-forming region, a nursery of gas and dust collapsing under gravity. In those early moments, newborn worlds collided and scattered, and among the debris a single shard was cast outward with just enough speed to escape. From that instant, 3I Atlas belonged to no star, no system, only to motion itself. For millions of years it drifted through interstellar clouds. Within those clouds are atoms of hydrogen, traces of carbon and oxygen, and the perpetual drizzle of cosmic rays. Each ray struck the surface like a spark on cold stone, breaking molecular bonds, forging new ones. Hydrogen and oxygen recombined into strange peroxides, methane turned into long carbon chains, and simple nitrogen compounds knitted into organic films. The ice that was once clear became amber, then dark, until the object glowed faintly red under distant starlight. As it crossed the spiral arms of the galaxy, 3I Atlas moved through regions of differing energy. Some sectors were calm, their radiation gentle. Others seethed with remnants of supernovae, where cosmic rays swarmed in densities 1,000 times greater. In those zones, the chemistry on its surface changed faster, more violently. Molecules shattered and reformed, atomic lattice lost their order. Each encounter layered the object in a complex skin, a geological history written not in rock strata but in molecular rearrangements. Imagine looking beneath that surface, a millimeter below, compounds rich in carbon. A few centimeters deeper, frozen ice is still laced with traces of ammonia and methanol. Beneath that, untouched material an archive of its birth cloud. Between each layer lies a record of where the traveler has been, of how the energy of the galaxy has sculpted its face. During passages near young clusters, ultraviolet light added its own signature, bleaching some regions, energizing others. Then, as it passed into darker lanes of dust, temperature dropped again and the altered molecules froze in place. Over countless cycles of heating and freezing, the crust hardened into an armor strong, inert, and black. Somewhere along that route, perhaps a supernova detonated within a few light years. The blast wave carried heavier elements iron, nickel, cobalt, each atom a tiny fingerprint of stellar death. When those atoms collided with 3 ATLAS, a few became embedded in its surface, trapped like meteorites in ice. To find such traces would be to prove that the traveler once crossed the ruins of an exploded sun. Through this chemical odyssey, a paradox emerged: exposure that destroys also preserves. By sealing itself in radiation-forged carbon, 3 ATLAS protected the fragile ices below. Beneath that layer, pristine matter has likely survived intact since the dawn of its origin system. If one day a probe could sample that interior, it would read a frozen memory from a star we may never see. As it journeyed, gravity from passing stars gently bent its path, nudging it closer or farther from the galactic plane. Over tens of millions of years, those perturbations changed its velocity until, by sheer chance, its course intersected the solar system. From our perspective, it appeared suddenly an intruder arriving from nowhere. But in truth, we were simply standing in the way of an ancient voyage. Chemistry and motion intertwine in such a traveler. Every impact of energy alters both structure and destiny. Cosmic rays make the surface denser, lowering reflectivity and slightly changing the way sunlight pushes against it. That change, in turn, adjusts its trajectory by infinitesimal degrees. Across millions of years, those tiny nudges accumulate, steering it through gravitational corridors like invisible hands. Thus, even the chemistry of its skin becomes part of its navigation through the galaxy. To the human eye, this is abstract, but in the mathematics of motion, 3 Atlas is a masterpiece of endurance, an object that is balanced between chaos and order. For instance, its path a signature of the galaxy's architecture. Each spiral arm it crosses is a new environment. Each collision with cosmic dust, a subtle repainting of its exterior. It is, quite literally, a moving laboratory, one that has conducted an experiment for as long as the Milky Way has turned. We can imagine the final approach toward our neighborhood. After uncounted revolutions of the galaxy, the object drifts into a region where the sun's gravity begins to dominate. Solar wind meets interstellar wind. Magnetic fields twist. For the first time in untold ages, light from a specific star warms its crust. The hardened layer barely responds, proof of its long transformation. Where once a young comet might have erupted in gas and flame, 3 Atlas remains silent, its chemistry stable, its secrets preserved. In that silence lies knowledge, the understanding that cosmic rays do more than scar surfaces, they rewrite them into resilience. They turn fragile ice into durable carbon, volatility into permanence. This is the chemistry of transformation, the alchemy of endurance. The galaxy forges its travelers not for comfort, but for survival. And so, as 3 Atlas now recedes into the dark once more, it carries with it the sum of that odyssey. Every molecule on its surface is a record of the distances crossed, every alteration a line of poetry written by radiation and time. To study such an object is to read the biography of the Milky Way itself. In the next and final chapter, we will look beyond the chemistry to the meaning of it all, how these cosmic processes connect to the origins of life, how interstellar visitors tie our small planet to the grand machinery of the galaxy, and how, in their quiet passage, they remind us that transformation is the universal law. Somewhere in the dark beyond Pluto, 3i Atlas continues its slow retreat, carrying the quiet music of everything it has endured. We will not see it again. But what it has shown us remains, a small, tangible reminder that matter itself remembers the chemistry of the cosmos, keeping a record of energy, radiation, and time. From that memory, a deeper question rises: what does this mean for life? If cosmic rays can sculpt molecules, if radiation can both destroy and create, then perhaps the chemistry that gave rise to us began not in the safety of planets, but in the wild of interstellar space. Every cosmic ray is a traveler from a dead star. When it strikes an icy surface, it rearranges atoms into more complex patterns. From simple ice as water, methane, ammonium alcohols, aldehydes, and amino precursors. On Earth, we call them organics. In the galaxy, they are the alphabet of possibility. The same radiation that darkened 3i Atlas may have written the first words of biology elsewhere. Imagine countless fragments like it drifting between systems, each carrying billions of tons of this processed material. Some collide with planets, some dissolve in atmospheres, seeding new environments with the raw ingredients of chemistry. It is not difficult to see how, over cosmic time, such exchanges could link worlds, how a chain of collisions and impacts might weave together the narrative of life across the stars. In this view, 3i Atlas is more than an object, it is a messenger. It tells us that the boundary between the living and the non-living is not fixed but forged one molecular rearrangement at a time. The galaxy itself is an engine of evolution, and cosmic rays are its restless artisans. For centuries, we imagined the universe as still and cold. Now we see it as alive with transformation. Even the darkest void is not empty. It is filled with flux, with energy moving through matter, with ancient particles carrying the signatures of a million suns. Every molecule of our own bodies has felt that same touch. The carbon in our cells, the iron in our blood, the oxygen we breathe, they were all shaped in stellar explosions and processed by radiation before finding a home on this small planet. So, when we study 3i Atlas, we are not peering at something foreign. We are looking at ourselves, at the shared chemistry of the cosmos. Its journey is the longer version of our own, stretched across epochs instead of lifetimes. It shows us that creation is a continuous act, not a moment. Perhaps somewhere, another civilization looks toward its sky and sees a visitor from beyond, scarred by cosmic rays, glowing faintly red. Perhaps they wonder, as we do, whether such travelers carry the seeds of beginnings. And perhaps in the endless drift between stars, fragments from their world are even now crossing paths with ours, unseen and unmeasured, exchanging the dust of life across the galaxy. The implications are profound but also humbling. We may never intercept 3i Atlas. We may never sample its interior or confirm every theory. Yet the evidence already reshapes how we think of the universe, not as a stage on which matter acts, but as a continuous conversation among energy, time, and structure. Cosmic rays, once feared for their destructive power, reveal themselves as the sculptors of resilience. They are the threads that tie the smallest grain of dust to the largest spiral arm. Through them, the galaxy recycles its matter and, perhaps, its potential for life. If that is true, then every interstellar object is a story in motioniverse and the ongoing poem of creation. When we look at the faint point of light that was 3i Atlas, we are not witnessing an ending but an echo, a continuation of the same processes that began long before the sun was born. It drifts now beyond the orbit of Neptune, out past the Kuiper belt, and back into the interstellar medium. Cosmic rays will resume their slow work upon it, darkening it further, deepening its crust of complex carbon. Long after our species has vanished, long after our planet is gone, it will still be out there, proof that the universe remembers every act of energy it performs. So, when we lift our eyes to the night sky, let us remember that the light we see and the darkness between it are not opposites. They are partners in the same dance, each shaping the other. Just as radiation sculpts 3i Atlas, adversity shapes endurance. Just as destruction forges creation, time distills meaning. The next time you see the stars, know that they are speaking in particles as well as photons, whispering across gulfs of silence to everything that exists. And among those whispers are stories like this one: a single traveler altered by cosmic rays, carrying within its atoms the memory of the galaxy. If you have followed this far, if this journey through radiation and matter has stirred your imagination, remember to stay with it. Subscribe, not only in the literal sense, but to the idea itself, that wonder is an act of attention, that curiosity is our most human way of belonging to the universe. For in the end, 3i Atlas is not just an object moving through space. It is a reminder that the cosmos is always writing, and that every atom, every ray, every drifting stone is part of a single and ending story. And we, for this brief moment of awareness, are the ones lucky enough to read it.